Hello, students. I'm getting into the mathematical connections. There's not a ton of math connections here, so I'm having you do a block from 1 through 4 and 13 through 16. So let's see here. Some of them, if you watch the other video or kind of saw what we did in class or what we're going to do in class, some of these should already be apparent. Can two non-zero whole numbers have a greatest common multiple? So I'm not going to answer that one. That was already covered. But again, if you're struggling with this, take two numbers, even if they're small numbers, and start writing out their multiples. Find what they have in common. Hopefully you see that it's a sequence, an arithmetic sequence. And you can ask yourself, what is the greatest term in that arithmetic sequence? That greatest term would be the greatest common multiple, if it exists. Let's see here. Question 2. Is it true that the GCD of three numbers multiplied by the LCM of three numbers is equal to the three numbers multiplied together? And then you can explain your answer. So you know it works for two. Usually when students in your class see something works for two, they do often try to generalize it. They say, if it worked for two, it's got to work for three. So be able to provide either an example, counterexample, and kind of say, hey, be careful. Here's why. Especially something with prime factorization. I think that would be kind of a good way to demonstrate that for a student. Let's see here. Suppose the GCD of three numbers is 1. Does that mean that the GCD of any group of two of those numbers is also 1? It's a good question. Is it true? Can you find some examples or counterexamples? That would work. Let's see here. Suppose the GCD of AB is the same as the GCD of BC, which is 2. Does that always imply the GCD of ABC has to be 2? All right, so again, and this one's a little bit more general, but you're welcome to try two numbers that have a GCD of 2. Then you add a different, so an A, B, and a C. So you need two numbers, A, B, and C, where the first two have a GCD of 2, and the last two have a GCD equals 2. Does that mean that when you put them all together, you end up getting 2 as the GCD? That's what the question's asking. Okay, so 1 through 4, I think I said 1 through 4 and 13 through 16. Okay, so now you get some questions from the classroom. Okay. Let's see here. (13 through 16). So Eleanor claims a GCD of 0, comma A is 0. Is she correct? So when you're answering questions like this, remember, as a student, they're trying to say, oh, GCD of 0 and A is 0 because 0 doesn't have any factors, so the answer is 0. Remember, in order to be a divisor, it has to divide both numbers. So if somebody said the GCD of A and B is equal to 5, then what do we know? I know 5 has to divide A and 5 has to divide B. Okay. Let's see here. Yeah, I think that's probably the easiest way to do it. Yeah, so is the student correct? Are they making is there a misconception here? How would you assist them in understanding whether they are or are not correct? And what would, if they are incorrect, what is the correct value for the GCD of 0 and A? 14, a student claims GCD does not exist. Okay, so again, if it does not exist, what does that represent? What does that mean? Is the student correct and why? Let's see here. We have Aiko. Aiko says to find the least common multiple, you can multiply the two numbers. As a teacher, how do you respond? Hey, want to find the LCM? Let's multiply them together. Seems to work. And again, it's not a problem with kind of asking a student, hey, where did you get that from? Why do you think that is true? And lastly, a student wants to know how many whole numbers between 1 and 10,000 are either multiples of 3 or multiples of 5. She thinks the way you go about doing that is you find all the ones that are multiples of 3 and you add all the ones that are multiples of 5. So what do you think about this strategy? How do you respond? Okay. Again, use those problem solving strategies we had back in chapter 1, because like from 1 to 10,000. Yeesh. That's huge, right? You don't want to try to even think of writing all those numbers out. So maybe shrink it down like we did even with the canoe problem. We would take the canoe problem and instead of doing a 11-person boat, we broke it down to a 3-person boat or a 5-person boat. So do that sometimes. You don't have to solve the big problem first. Maybe solve a smaller one. And I think it would be a little bit easier from there. All right. That's it for now. I'll probably have some videos about the exam or at least the concept review sheet coming up soon. Hope you have a good rest of your day. All right, off you go.